6.1 goes over properties of exponents. With these exponents, they're also called powers. You have certain properties or rules that go with them, which this section will go over. Anytime you have something that is raised to the power of 0, your term automatically turns into 1. Anytime you have a negative exponent, you're going to take the reciprocal of the term that it's attached to make that exponent or that power positive. If we look at example 1a, we have 6.7 to the power of 0. Again, anything raised to the power of 0 is automatically 1. So this is just 1. For example B, we have negative 2 to the power of negative 4. So because this negative 4 is a negative, we want to turn it into a positive. We're going to take the reciprocal of that negative 2, which is 1 over negative 2 to the 4th power. That turns our 4 into a positive 4. Now we can multiply this negative 2 by itself 4 times. Another thing that I like to do with these is to separate whatever's inside the parentheses. So yes, this negative 2 is in parentheses, but that negative is saying the opposite of 2 raised to the 4th power. So what this really is it's telling you to do the negative 1 to the 4th power as well as the 2 to the 4th power. So the negative 1, anytime it's raised to an even power, it's going to be positive. Anytime it's raised to an odd power, it's going to stay negative. So this is going to become 1 over 2 to 2 times itself 4 times, which just gives us 1 over 16. Whenever we write these answers or we evaluate or simplify these expressions, we want to make sure our answers end with positive exponents if we have any exponents left over. In these cases, these powers are just attached to numbers, so you will not end with a negative power. For example, C, we have a negative 9 raised to the power of 0. So because that entire thing is in the parentheses and being raised to the power of 0, we just get 1. Because again, anything raised to the power of 0 is automatically 1. For D, we have 3 to the negative 3rd power. So again, to turn the negative 3 into a positive 3, we're going to take the reciprocal of 3. It's 1 over 3. We're going to raise that 3 to the 3rd power. So that's 3 times 3 times 3, which is 1 over 27. If we look at our next part within this lesson, we're working with these fractions with the terms that are raised to powers. So if we look at example A, we have 4x to the power of 0 all over y to the negative 3rd. We got to do two things here. We got to first simplify that x to the power of 0, which is automatically 1. That 0 is only attached to the x, so that's why that x is just turning into the 1, not the 4. The 4 stays, so it's going to be 4 times 1 now over y to the negative 3rd. Now, we still have to make that negative 3 a positive 3, so we're going to turn it into a positive 3 by bringing that y to the 3rd up top. So 4 times 1 is just 4. Then we multiply it by y to the 3rd, which just gives us 4y to the 3rd. For example B, we have negative 5 to the power of 0 over 2 to the negative 2nd power. Now, with this negative 5 to the power of 0, the only thing that's being raised to the power of 0 is the 5, not the negative. If it was in parentheses like this, then it would be the negative 5 to the power of 0, but it's not. It's just the 5. So that 5 is what's turning into a 1, so that's a negative 1 over 2 to the negative 2nd power. Now, since you've gotten this far, turn the negative 2 into a positive 2, bring it up top. We're going to have negative 1 times 2 squared. 2 squared is 4, so that's negative 1 times 4, which is just negative 4. For example C, we have 3 to the negative 2nd power, x to the negative 5th, all over y to the power of 0. If you want to simplify that y to the power of 0 first, you can do so. It's just going to turn into a 1, so it's just the 3 to the negative 2nd power x to the negative 5th power over 1, which is just the 3 to the negative 6th, 3 to the negative 2nd, x to the negative 5th. Now turn the negative 2 and the negative 5 into positives. Take the reciprocal of them. So this is going to be 1 over 3 squared times x to the 5th power. That 3 squared is 9. So simplify this. It's just 1 over 9x to the 5th power. So for our next set of examples, we're just simplifying expressions that deal with these powers. So if you are multiplying and your bases are the same, you're going to be adding those powers. If you're dividing and your bases are the same, you can subtract those powers. And if you have a power raised to a power, you multiply those powers. So in example A, we have 3 squared times 3 to the 6th power. Because our base is 3 on both of these parts, we can keep the base, add the exponent since it's multiplication. So we're going to keep the 3, add the 2 and the 6. This gives us 3 to the 8th power. Now with this, you could also simplify this further. That 3 to the 8th power would be 6,561. I'm not going to require you to go that far for a term like this that's much larger. So I would just tell you to give me this 3 to the 8th power on something like a quiz or a test that deals with this section. For example, B, we have negative 4 raised to the 2nd power over negative 4 raised to the 8th power. You have a base of negative 4 on both the top and the bottom here of this fraction. So you can keep the negative 4 and just subtract those exponents. So we have negative 4 raised to the 2nd power minus the 7th power. 2 minus 7 gives us negative 5. So it's negative 4 raised to the negative 5th power. We got to turn that negative 5 into a positive 5. So take the reciprocal. That's 1 over negative 4 to the power of 5. That negative 4 to the power of 5, you're doing the negative 1 to the power of 5, which is going to leave you with a negative. And then that 4 to the 5th power would be 1,024. For example, C, we have z to the 4th power raised to the negative 3rd power. So we have a base, which is that z. We have that 4, that's our original power, and then it's being raised to the negative 3rd power. So because we have a power raised to a power, we're going to multiply those powers. That 4 times the negative 3 gives us negative 12. So that's z to the negative 12th power. We do need positive exponents in our answer. So we're going to take the reciprocal of this and just have 1 over z to the 12th power. For example, D, we have 10 to the 4th power times 10 to the negative 6th power. For this 10 to the 4th power and this 10 to the negative 6th power, they have the same bases, so we can keep that 10 and just add those powers since we are multiplying. So the 4 plus negative 6 is negative 2. That's 10 to the negative 2nd power. We turn that negative 2 into a positive 2 by taking the reciprocal. So it's going to be 1 over 10 squared. The 10 squared is 100. So that's just 1 over 100. For example, E, we have x to the 9th power times x to the negative 9th power. So with this one, our bases are the same and we're multiplying. So we're going to keep the base, add the exponents. 9 plus negative 9 is just 0. So that's x to the power of 0. Anything raised to the power of 0 is 1. For example, F, we have negative 5 to the 8th power over negative 5 to the 4th power. That negative 5 is our base. It is the same on the top and the bottom. Since we're dividing, we're going to subtract those powers. So 8 minus 4 is just 4. That's negative 5 to the 4th power. A negative raised to an even power is going to become positive. 5 to the 4th power is 625. For example, G, we have y to the 6th power over y to the 7th power. Another way to do this when your when your bases are the same and you're dividing, you want to look to see where the bigger power is. Your bigger power is in the denominator of this fraction, so you're going to end with that base in that spot within that fraction. So because it's in the denominator, we can still just move this down or subtract these two. This is going to cancel out to be 1. You're going to subtract this from the 7, and you're going to have 1 over y to the 1st power, or just 1 over y. Again, you could have subtracted. You would have had y to the 6th power minus the 7th power, which gives you y to the negative 1st power, which is just 1 over y. So either way, you do get the same answer. It just depends on your preference on how you do it. And then with example H, we have 6 to the negative 2nd raised to the negative 1st. We're going to keep the 6. The negative 2 is being raised to a power, so we're going to multiply the negative 2 by the negative 1. This gives us 6 squared, which is just 36. In example I, we have w to the 12th power raised to the 5th power. So again, we have a power raised to a power. We'll keep the w, multiply the 12 and the 5. We get w to the 60th power. For your 4th part, you're just using properties in order to simplify these. You want to remember, if something's in parentheses, you're applying the power to every part in the parentheses. So in example A, we have 1.5y raised to the 2nd power. So this 1.5 and this y are both in the parentheses. If you want to rewrite it as 1.5 times y within brackets raised to the 2nd power, you can do that. So that way it reminds you that that 2 is going to be the power on the 1.5 as well as the y. The 1.5 squared is 2.25, and then that y squared is just y squared. So we have a final solution here of 2.25y squared. For example B, we have a over negative 10 to the 3rd power. Again, because that 3 is on the outside of the parentheses, it's going to go to the numerator and the denominator. So it's going to be a cubed over negative 10 cubed. That a cubed is just a to the 3rd power. That negative 10 cubed, negative 10 times negative 10 times negative 10, is going to give us a negative 1,000. That negative does go in front or on top of that fraction. So I'm just going to move this negative out front of the fraction to give us negative a cubed over 1,000. For example C, we have 3d over 2 raised to the 4th power. So we're going to take that 4 and have it be the power on both the 3d as well as the 2. So I'm just going to rewrite this to be 3d to the 4th power over 2 to the 4th power. The 3d to the 4th power, that 3 is going to be raised to the power of 4. That d gets raised to the power of 4. So that 3 to the 4th power is 81. D to the 4th power is d to the 4th. And 2 to the 4th power is 16. The 81 and the 16 cannot be simplified, so we leave it 81d to the 4th power over 16. For example D, we have 2x to the negative 5th power over 3. Now you can do this one of two ways. You could apply the negative 5 to the power of both the numerator and the denominator, or you can turn it into a positive 5 first and then do that. I would turn it into a positive 5 first by taking the reciprocal of the fraction. So this is going to be 3 over 2x raised to the 5th power. So then that 3 gets raised to the 5th power, as well as that 2x gets raised to the 5th power. The 3 to the 5th power gives us 243. And remember on the bottom that 2 is raised to the 5th power as well as that x is raised to the 5th power. So this is going to leave us with 243 over 2 to the 5th power is 32, x to the 5th power. For our next example, E, we have 10y to the negative 3rd power. So once again, I'm going to get rid of this negative power first, so that way I'm not working with a negative power, and just take the reciprocal of that 10y. So the reciprocal of the 10y is 1 over 10y. So I'm going to have 1 over 10y raised to the 3rd power. Now that my power is positive, I'm going to apply it to both my numerator and my denominator. So I have 1 cubed over 10y cubed. The 1 cubed is just 1, and 10y cubed is going to be 1,000y cubed. For example, F, we have negative 4 over n raised to the 5th power. We have a positive power here, so we can just apply it to the negative 4 to the 5th power over n to the 5th power. That negative 4 to the 5th power, remember, it's like saying negative 1 to the 5th power times 4 to the 5th power. And then that n to the 5th power is just n to the 5th power. So negative 1 to the 5th power is going to leave you with a negative. 4 to the 5th power is 1,024. And then we keep it over n to the 5th power. So that's just negative 1,024 over n to the 5th power. For example, G, we have 1 over 2k squared all raised to the 5th power. So again, I'm going to apply that power to both the numerator and the denominator. So it's going to give us 1 to the 5th power over 2k squared to the 5th power. So again, I want to think on that denominator. I have more than one term practically in the denominator in those parentheses. So the 5 is going to go to both the 2 and the k squared. So that 1 to the 5th power we know is just 1. We're going to have 2 to the 5th power as well as k squared to the 5th power in the denominator. So this is going to turn into 1 over 2 to the 5th power is 32. K squared to the 5th power, we multiply the 2 times the 5 to give us k to the 10th power. So it's just 1 over 32 k to the 10th power. For example, H, we have 6c over 7 all raised to the negative 2nd power. So again, I'm going to apply that negative 2 to both the numerator and the denominator first, or because I have a negative exponent, I want to turn it into a positive, take the reciprocal, and then apply. So I, again, don't want to work with the negative power, so I'm going to take the reciprocal of the 6c over 7 to give me 7 over 6c all raised to the positive 2nd power. Now that I have that positive power, I will apply it to the numerator and the denominator to give us 7 to the 2nd power over 6c to the 2nd power. The 7 squared is 49. The 6c to the 2nd power is 36c squared. So the last example that we're going to go over asks you which of the expressions shown represents the volume of the cylinder. It gives you the hint that your volume is equal to pi times your radius squared times the height. Well, if we look at this cylinder, your radius is that height divided by 2. So we're just going to plug that in for the radius. So our volume is equal to pi times the radius squared times the height. This is your radius. So we're just going to plug that in. So volume is equal to pi times the radius, which is h over 2 squared, times the height. We're gonna apply that 2 as the power to both the numerator and the denominator there. So we're going to have volume is equal to pi times your height squared over 2 squared times the height. So this is going to give us our volume is equal to pi times h squared over 4 times our height. If we multiply everything, we're going to do volume is equal to pi times your height squared times h, and everything's going to go over 4. Remember, when you multiply two bases that are the same, you can add their powers. So we're just going to add the 2 and the 1 to give us our volume is equal to pi times our height cubed over 4. So if we look at those different boxes, that 1 in the bottom middle is our expression that we're looking for.